eruption here near Grindavik, and we have cleared the town and the area, and now we're just securing the area.
Before time, before the world, there was Ginnungagap, a void between Niflheim and Muspelheim. Niflheim, a dark ice place of frost and fog. Muspelheim, a place of fire, lava and smoke, inhabited by fire demons and giants. A great river sprung from Niflheim, flowing down the mountains to the plain of Ginnungagap, where it froze and spread out in all directions. It is here where it met the fire of Muspelheim, and that the ice melted and it took on the form of the giant Ymir. It is from these primal forces that the Viking gods emerged, along with Asgard and eventually the world of men. It's not hard to imagine what inspired these stories when Vikings first settled Iceland over 1,000 years ago. Iceland has now become known as nature's theme park. The country's allure lies in its breathtaking glaciers, cascading waterfalls, and the powerful volcanoes that punctuate its landscape. And if you've been following the news, there's been the excitement of the rumblings of a new attraction, which after months of expectation broke the surface, stopped, started again, stopped, and this will continue. The volcanism of Iceland is not a deep sleeping giant. The fire demons take short naps. With this latest volcanic activity hitting the news, I want to share my recent visit to the island and present the context and scientific understanding alongside the pleasure of experiencing the country. Icelanders have every reason to fear eruptions. They're destructive and destroy homes, businesses and livelihood, but the country is well prepared and those evacuated from their homes and unable to work are protected. For others, eruptions are exciting and great for tourism, as the country is very organised in making new volcanic attractions safe and ensuring adequate parking, all at very good rates. But this eruption is different. It's in an area that last saw activity 800 years ago, and it seems it may be in a volcanic cycle where there's more activity. The fear is that land built on near Reykjavik was also active 800 years ago, but more on that later. Now, some may be disappointed that Earth's great theme park may not have attractions available when they visit. An example is Giza. The geyser, or the one who gushes, that gave the name to all other geysers. The normal clockwork ejection of hot water is changing. It seems to be moving along just as it has over the centuries. Now, personally, I'm just chuffed to be here. But there's some real disappointment among many of the visitors waiting for the spectacle that is currently having some technical issues. And with this in mind, don't be sad that the main feature of erupting lava may be offline. Previous eruptions have lasted days, months, and sometimes a couple of weeks or so. But whilst flowing lava is spectacular, much of the real action is going on beneath the surface, and this is where the subject gets interesting. Iceland is a place where the power of the Earth's heat engine meets the power of the elements, and all of this in real time. A barrier to enjoying the study of geology is the mind-bending times involved in the building of Earth's landscapes. Geologists talk not just in millions of years, but hundreds of millions of years, if not billions of years. But here in Iceland, mountains are being thrown up within human history. Land can appear overnight, and simultaneously ice, wind, frost and waves, and even plants are constantly eroding this new rock into dust and sand that go on to form new rocks in the future. Science, and I'll be referring to the Icelandic Met Office, who provide valuable insight and data on the volcanic activity, is very good at understanding what's going on under the surface, and a few kilometres deep. The Icelandic government is very good at managing the hazards and allowing visitors to safely spectate the greatest show much on Earth, but also from Earth. For For a visual understanding of what's going on beneath the Icelandic surface, we would have to wait millions of years for the land to be uplifted and eroded away. Scotland, however, offers fabulous examples at the surface. The Inner Hebrides, particularly Skye and Mull, show the inner workings of volcanoes that have risen to the surface, and the top layers have been eroded away. The hotspot deep in the Earth's mantle that is creating Iceland was possibly once under Scotland. Iceland has its origins a mere 20 million years ago. The oldest rocks on the island are no more than 16 million years old. It is, in geological terms, just a baby, and is still growing, and these growing pains can be seen and felt now. The latest volcanic activity started with a swarm of earthquakes around the small fishing town of Grindavik. Now, earthquakes come in three different types. There's compression, where the rock is being pushed together, lateral slips, where the rock slips past each other suddenly, and extension, where the rocks are being pulled apart. And this is what's happening in Iceland. So sudden and so dramatic that even though it's happening 1,000 or more meters underground, that ripping apart is seen on the surface. The track we see is in fact subsidence. The land has been pulled apart, but what we are seeing is the top surface collapsing into the void. The steam you see is not volcanic. Well, not directly. It's hot water for heating piped into the town from the nearby geothermal power plant. The reason these cracks are appearing is that Iceland straddles a fault, the North Atlantic Ridge, which gets wider by about 2.5 centimeters a year. But that movement is an average, and it's focused not only in time but also in location, leading to sudden splitting, which is often localized. 50 million years ago, that splitting was occurring in the Inner Hebrides in a series of cracks that ran up from Northern Ireland to the Isle of Skye. It all calmed down millions of years later and resumed between southeast Greenland and beyond the Scottish mainland. It may seem like that Greenland and North America on their tectonic plate is being pulled away from Europe on its Eurasian tectonic plate, but in fact the two plates are moving in opposite directions, creating a gap that allows magma to flow up, to literally escape the Earth's magma and fill the gap with lava. Now the whole of the North Atlantic is widening, so how come it's Iceland that is the only major landmass? Well, Iceland sits on a particularly active hotspot. Simply more magma escapes. Why a hotspot occurs is still not fully understood, but it's partly self-explanatory. It's a plume that's hotter, and that heat makes the mantle more fluid, which in turn allows it to rise to the surface. Whilst the continental plates are mobile, that is, the Earth crust floats and slides over the mantle itself doesn't move. This is evident looking at another hotspot of Hawaii, where you can see the plate has moved over the hotspot, and periodically lava reaches the surface, creating a chain of islands. This plume or hotspot may be as deep as 2,800 kilometers, where the outer core of the Earth meets the mantle. But there's competing theories. Suffice to say, Iceland is special. As mentioned, a key element of volcanic activity is this movement of continents. Huge land masses that float around on the surface of a fluid-like hot magma. But it's important to remember that magma is not glowing red. It has to reach the surface of lava to emit light, and counterintuitively, by losing heat, those excited atoms of rock lose a little energy as light. Magma is really incredibly slow-moving solid, moving just a few centimeters a year. Think of it more like hot cookie or biscuits straight out of the oven. Magma is very hot rocks over 1,000 degrees C, but they're under extreme pressure, so it doesn't, boil. That is, it doesn't go from a solid to a more liquid or gaseous state. Nearly all of humanity lives on continental plates, the continents. Iceland is oceanic. So let me explain. Look out across the sea, and it's really a flooded continent. Flooded land. Much of the North Sea was dry 10,000 years ago or so. On continents, land is thicker, layers of rock, and that rock will be made of strata of different rocks. Old rocks and continents can avoid being eroded away or consumed back into the mantle for millions, if not billions of years. Iceland is different. It's young and born from the ocean floor. Its mountains have not been pushed up in great mountain-building episodes, although there is some uplift. They have grown from the top down by successive layers of lava, pushed to the top of these peaks and filling in the valleys. Look at a cliff elsewhere in the world and it will display the slow accumulation of sediments. The strata in the cliffs of Iceland has been formed in eruptions. Geology in an instant. Closer to the surface, literal cracks in the crust are filled with magma. As it rises, it becomes more fluid as pressure is reduced. It's rather like taking the lid off a fizzy drinks bottle. An early warning of an eruption, that is, when the magma reaches the surface and becomes lava, is the release of gases, just like a fizzy drink. The magma is depressurizing, making it more liquid. Iceland has sensors. Carbon dioxide is the major gas being released, as well as water vapor. The most obvious gas, at least to your nose, is hydrogen sulfide, that smell of rotten eggs. This vent may look stunning, but it stinks. However, on this occasion, the hydrogen sulfide is generated relatively close to the surface, as groundwater sinks down and reacts under the heat with the sulfur in the rocks. The sulfur gas from deep within the earth is different. The population of Grindavik were evacuated when high levels of sulfur dioxide was detected, and that indicates an imminent eruption. But it's also a dangerous gas. Sulfur dioxide has a stinging odour and smells similar to a burnt match. Carbon dioxide can also be hazardous, as it's a relatively heavy gas in high concentrations, such as a confined space, and it will suffocate people. And whilst volcanoes are the biggest added natural source of CO2 in the atmosphere a year, the global volcanic activity is worth about 3 days' worth of humans burning ancient carbon fossil fuels. The current fissure, each day, emits about the same amount of CO2 as Britain's second city, Birmingham, does in a day. Magma that travels up through a fissure eventually comes to a halt and solidifies. Over millions of years, erosion bites down into the surrounding softer rock to reveal strange natural walls. This is one of the largest ancient wall or dike in Scotland. Its width an indication of the sudden gap opened up by the movement of continental plates. There are some nice examples on Mull and a swarm of dikes on the Isle of Arran. These lava walls stretch deep into the Earth's crust, and it gives an idea of the plumbing currently under Iceland. This episode of volcanic activity, this crack is about 15 kilometres in length, and follows the divergent fault that cuts across the island. And divergent faults are also known as constructive faults. However, the fault, just like a crack in a building, is not neat and even, and it will follow weaknesses in the rock. Magma may take a more independent route to the surface, being more like a tube. In 2010, the magma pooled in a chamber.
In Eyjafjalla, Lækjarköl.
This chamber is called a caldera, a cauldron, when it has emptied. We can visit these empty geological structures, although weathered in Scotland, the most famous being Glencoe, formed hundreds of millions of years ago. The empty chamber collapsed under the weight of the volcano above, and has been eroded to reveal the rocks and the remnants of magma. Rocks don't go off, so geologists can analyse the chemistry of the rocks, get a picture of what's going on under Iceland today. Kirid crater is about 30 kilometres east of the current activity. It erupted about 6,500 years ago. And being a shallow caldera and small, we can wander around the not-so-ancient interior of this small cone volcano, long since eroded. When the lava was ejected, the volcano collapsed and allowed for this lake to form. The red volcanic rock is a feature of the oxidation process. And it's rusty, it's got ferrous iron. The magma from the
in Eyjafjallajökull.
volcano is more viscous in nature, slower moving, and having more gas dissolved into the magma. But what made this eruption more explosive was the amount of groundwater that had entered into the magma, and all under extreme amounts of pressure. On this occasion, imagine the fizzy drinks bottle has been shaken up before quickly releasing the gas, the escaping gas causing a violent eruption. And as the lava was carried into the air, into small sizes, it allows it to quickly cool as ash. Now, these small dust-like particles we may call ash, but it's nothing like the ash you find in your barbecue. Volcanic ash is tiny flakes of glass. And the danger to aviation was not so much the abrasive nature of the dust, although that was an issue, but the dust would melt onto the jet turbines and then cool into blobs of glass that would interfere with the efficiency and the reliability of the engine. Here at the foot of a long dormant volcano, people have made caves by tunnelling into it. At Lagavan, it's a good place to see different types of material ejected by the volcano. There's tephra, large particles, boulders, ash and bombs. Along the
Reykjanes
peninsula, as in 2021 and 2022, the lava is running, and most of the gas is escaping before it reached the surface. Likewise, the eruption was along a fissure. Magma does not always reach the surface. This is known as an arrested dike. Lateral weaknesses in the rock, perhaps the boundary between strata, causes the magma to spread out, pushing the overlying rock up and then slowly cooling in place, and this can be very thick. The overlying strata will often be a harder rock, arresting the progress of magma. Again, we have to wait a few tens of millions of years for erosion to strip away the overlying rock. The most dramatic in Britain is the windsill on which Hadrian built his wall. It stretches for over 40 kilometres south, where the southern edge is visible at high force. This volcanic activity occurred when Scotland started to separate itself from England about 300 million years ago. That attempted independence movement caused the crust to thin and the magma to push its way up to where it found a weakness in between the Carboniferous rocks, and then taking about 100,000 years to cool, and it shows off the columnar nature of the rock. Magma from deep underground is pretty consistent in composition, but as it travels up through the mantle, it may lose or leave behind some of its elements. It may lose gases. It may leave more silicate-rich material that will eventually solidify deep underground and expose as granite. And as magma gets closer to the surface, it may pass through different layers of rock, that were lava or tuff or ash. Running lava from a fissure from a couple of years ago forms these distinctive patterns on the surface, like a skin of custard. This is rope lava because it looks a bit ropey. As soon as this brand new rock is made, it's immediately eroded by the elements. First, the cooling effect. The smooth, homogeneous lava cracks into larger lumps as it cools down. Frost, rain will break the lava down. And even the Icelandic moss does its bit. Of course, waterfalls have their impact. The column-like nature of magma, caused by the even formation of rock crystals, creates spectacular falls. If the magma cools and it's insulated, either under the surface or under mud, it forms columnar lava, which is allowed to cool slowly. The columns forming at 90 degrees to the cooling surface, such as mud. Occasionally, lava erupts under a glacier, as it did with
Kötlujökull.
and previously
Mýrdalsjökull.
nearby, just north of Vix. So what happens when the fire demons misbehav meets the icy river and Niflheim. Who wins? Well, a ton of lava will cut through ice, but only turn a couple of litres of ice into steam before it's cooling down. But the volume lava means that there are huge meltwaters, creating a flood, one so powerful it swept away roads and bridges. Iceland may be entering into a particularly destructive episode. Volcanic activity is cyclic. The latest fissures are occurring in an area dormant for centuries, 800 years or more, and it's close to where the airport is, and whilst most of Reykjavik is on lava dormant for thousands if not millions of years, building in the suburbs has spread on to younger lava. Given volcanism often occurs in these cycles of more extensive activity, things may get expensive for Iceland. Time will tell, and it seems this episode of volcanism will be long-running. But Icelanders are the most experienced in dealing with these fire demons. Now, as we marvel at the volcanic wonders of Iceland, it's important to remember that the magic of geology is not confined to far-off lands or exotic destinations. Our planet is a dynamic tapestry of geological stories waiting to be explored, and you don't have to travel far to uncover those wonders beneath your feet. Now, whether you're near a dormant volcano or a geological formation shaped by ancient lava flows, there's a piece of Earth's history waiting for you to discover. Volcanic geology isn't just about witnessing eruptions, it's about understanding the forces that shape our world and appreciating the beauty in those rocks and the landscapes around you. So, do take a stroll, go for a hike, and explore your lands. You might be surprised to find remnants of volcanic activity, ancient lava flows, or unique rock formations that tell the story of our planet's violent, fiery past. Thanks for watching. Do like, comment, and subscribe.